Hello everyone, GafTheMaster97 for you again today. I don't know how many times I'm going to fuck up this intro, but I'm doing a viewer requested tutorial about random trains. Now, if I show some video footage at this point, then I believe what Zachary wants me to demonstrate is essentially a random chain of trains. Yeah, chain of trains, say that 3 times fast. Where the first train is like an engine of some sort, and that's always the same, but then it's every subsequent carriage, if you will, that ends up going through some sort of pseudo-random process. So this is more like a follow-up to the logic case tutorial I would have covered a few years ago at this point. And I'm going to show my setup now. This is very bare basic, and I'm using Hammer++, so I'm just going to get rid of the tool textures for the time being, and the Hammer default no draw as well. That's going to make my life a little easier. But it's going to start in this tunnel down here, and there's a path track here. It's not going to show up as a path track just yet, but it's going to start here, and then it's going to go down here in a straight line, because that's just really easy. So go from point A to point B, and that's all it does. And quite simply, I've called the first path track train path 1 at the last place that you would saw it, and then orientation type no change, and simply an output that says on pass !activator and kill. So any train that passes this path track is going to get removed as soon as it passes. So I'm going to go into the trains first, I think, because that's going to make a lot of sense. Seeing as how this process works, what it's best to do is to try and create the train carriages as individual trains. So instead of making one big chain and make duplicates of the chain, instead what we're doing is just using individual localized instances of the trains and then just spawning them in when we want to spawn them. So I think I have to turn tool textures back on very briefly, because you see this is a func track train entity, which is tied to an invisible brush, that way you don't see it. And I've called this, for example, train 1 entity. This is the engine, the first train that's going to spawn in. And I've set its first stop target to be the first path track at train path 1. Never fixed orientation, that way it doesn't rotate. Height above the track 0, so it's not going to be floating above the ground. And also a move sound, not that that's really important. But what is important is this max speed, not initial speed. We don't want it to move initially, but we do want to set a maximum speed here. So if I just go over to my top-down view over here where the train is, you can actually see that the train is 640 units long. And again, 620 is just a little lower, because you can kind of see there's a little bit of a gap from the end of the train here, and maybe even a little bit at the start as well. So it's not perfectly aligned, but it's good enough. So the idea is, I'll get to it later, but just keep in note the 640 length and the 620 max speed. And under flags we want no pitch, so no X rotation, no user control. We have a fixed orientation, and they've also got is unblockable by the player, so the player can't block the train no matter how hard they try. And so if I go under the other trains as well, we've got what I like to call the closed setup, the open setup, and also the open with pods. Now the open with pods isn't just one model, it's a bunch of little models. So a bunch of the prisoner pod models like in Nova Prospect. But this gives 3 choices of train to spawn in. And so if I go under the model, for example, for the first one, they're all going to be pretty much the same. It's just parented to the train entity, give it a model name, give it a name, and then I don't think there's anything else that you need to worry about. So that's all you really need to do there. And inside of this train is a point template as well. So I've just called it something like train 1 template, and it's set to have a template of the entity and the model. And what's key is that in the flags we don't have any flags checked, because by default it sets to preserve entity names, which means it doesn't do name fix-up. But what we want to do is to do the name fix-up, so we untick that flag, and that's all we do there. Otherwise, what's going to happen is when these trains spawn, they're all going to have the same name, and because of that, on pass exclamation mark activator kill output on the end path track, that you'd probably just see some of these trains just disappear instantly, which is not what you want to have happen. So you want to give each spawned train a unique name. So that's why we set that flag the way we did. And just to show you the one with the pods, you can see that all the pods are in the template as well. So you can go up to 16 entities. And again, as I just showed you, no flag there. So then, because we're using point templates to spawn in the train, we're going to have to use an env entity maker entity to spawn them. So just go in here randomly, it's selected train 2. So all we have is call it train spawner. It's going to train 2 template, and there's nothing that we need to do here. That's all you really need to put in. And I've just put these entities exactly at the same place as the first path track. So for me to select it really easily, I just need to go to, this path track, select it, and then it's just got the same speed as the max speed of the train. And that is everything that we need to do there. Make sure you have no change as well. So that's all of the train setup at least. But all we really need to do now is have a way of spawning the trains in and having some sort of logic to follow. So here's my setup over here. It might look daunting and it might not make a lot of sense, at least in words, but hopefully you can follow along. So it starts with this logic timer over here, and I've called it a global train timer, and we've set it to use a random time. And with this setting being set, it basically fires an on timer output between this minimum and maximum refire interval. Now I've got it between 15 and 35 seconds. Maybe in your map you could do with having it a bit longer than this, but this is just for demonstration purposes only. And the only output we have is to go into a logic case called train number case, and we just say to pick random. So this is the train number case, and all it's going to do is specify the number of carriages to spawn. Now I've just put these numbers in here for reference. You don't actually have to put these numbers in because they're not going to be useful. But what is useful is the outputs. And so there's 6 logic relays. Each relates to spawning of a particular number of carriages. And so because the logic timer is going to pick random out of any of these cases, what we're going to say is, well, if it's 1, we want to spawn 1 train. If it's 2, then spawn 2. If it's 3, spawn 3, and so on and so on and so on. Now, if we spawn 1, we go to the far left over here, and it's just going to spawn train 1, and that's all it's going to do. Then if we go to train 2, it's going to spawn train 1, but after 1 second, it's going to go into a different logic case, and that's going to pick random of the either open, closed, or the open with pods trains, as I would have shown earlier. Then if it's 3, it's going to still be train 1 at the top, but then it's going to be a random train after 1 and a random train after 2. And then with 4, train 1 at the start, then a random train after 1, 2, 3, and get the idea. So it just continues on, and it just goes into this logic case at the end. And all we're saying is it's either going to spawn train 2 if case 1 is triggered, train 3, which is on case 2, and then train 4 on case 3. So that makes a little less sense, but it's open, it's closed, open, or open with pods. That's the order it goes in, and it picks random out of those 3. Is essentially what's going on there. And the reason I've done this time delay after 1 second is because of the speed and the length of the train, as I mentioned earlier, to keep in note. So because the length of the train is 640 and we've made it move at 620, after 1 second the train is going to move 620 units to the right, which then allows us to spawn in the next train, and then that's going to move 620 units to the right, and then you spawn in the next train. So it looks like a nice linkage. So as I might have said, because of the sort of placement of the actual from track train entity and the length and all that, it might not look like a nice chain if you set the speed to 640. So I said it's 620, it's slightly slower, but that means the trains are going to spawn closer together. Now, one thing that is really, really, really important is that all of the trains have about the same length. So if I disable tool textures for a moment, you can see that the front train is about 640, then the next train is about 627, the train after that is about 630, and the train after that is also about 630 in length. So again, it's ever so slightly off, but it's something that is really important to make sure that the flow looks as nice as possible. I know that from some of the other trains in Half-Life 2 have varying sizes, so that can make this incredibly awkward. It's the trade-off between length and time delay with the entities that I've got over here. So I've made it so every subsequent carriage spawns after 1 second, and that is, you know, partly because of the speed and the length of the train that I've specified. And so we don't even need to trigger the logic timer, it's just going to basically fire it at random. So if I save and compile this map, then what you should find is that the first logic case is going to determine the length of the train, essentially how many train cars are going to spawn in, and then every train after the front engine train is going to be random. It's either going to be closed, open, or open with pods, and theoretically speaking it's going to be different every single time that the trains spawn in, and it's going to spawn these trains in at any time between 15 and 35 seconds. So that is the logic, essentially. That is how this should work, and hopefully from following this video you can follow it for yourselves, follow along, hopefully understand what's going on here. And it might look a little daunting, a little complex, but it's really not that bad when you really think it through and understand what it is that you want to do. And so all I can really say is that I hope you found this helpful, and let me know what you think. Like it if you like it, dislike it if you dislike it, subscribe for more content, and I'll see you next time for whatever I decide to do next. So yeah, thank you for watching, and see you next time.